When you started working on problems in section 1.1, you may have noticed that problem 5 dealt with some symbols that you possibly haven't seen before. So I want to take a look at those. If you look at this diagram here, I have a triangle, and I have different segments, rays, and this funny U shape here. That U shape represents the term union of two geometric figures. And I really like that term union because the word means what it is. The union, very simply, is the combination. It unites together whatever the shapes are that you're trying to unify. So for example, the union of segment BE and segment EC will combine, unite those two segments together. I think the easiest way to do union problems is using a little bit of color, using a pencil. I trace over the diagram and I see what kind of figure I end up getting when I shade each of the parts included in the union statement. The final answer is just going to be the name of the shape that I shade. So I'm going to shade segment BE and shade segment EC and see what is that new shape that I end up getting. So you'll see that BE is right here. And you'll see that EC is right here. What did I end up getting here? Well, that new shape is a segment. It's a line segment that begins at B and it goes down to EC. So that would be segment BC. You'll notice the question B is a continuation of that. There's one little change. Notice this is segment BE. This is ray EC. And so the question is, does this change anything or do I end up with the same answer? So I've already shaded in segment BE. Ray EC would start here and it would continue. And drawing those arrows in is incredibly important because you've got to decide, is your final answer a line? Is it a segment? Is it a ray? You're not going to be able to tell that unless those arrows are there. So ray EC begins here and it continues out. And I'm going to go ahead and make the point that this goes on infinitely. And I'm going to draw that down there. And you'll see, again, the union, the uniting of that segment and that ray gives me something that starts here, but it continues on infinitely. It's a ray. Okay, how do you name a ray? You name the endpoint, in this case B, and you can either say that it's going out in the direction of E, or you can say that it goes in the direction of C, either one. So you could say ray BE, or you could say ray BC. Both are acceptable answers. Now, I didn't put this example up here, but a follow-up to that. Let's say that I have decided to do the union of line BE with ray EC. Line BE would go on forever in this direction. Notice I'm putting the arrow down here. Line BE would go on forever in this direction. Notice that EC is actually a part of it. EC starts here and goes down in this direction, and of course it ends with an arrow. And you'll notice I didn't add anything new on. So again, the unification of those two things just creates this line that goes through here. And in this case, that would end up being whatever you want to name that. You can name that line BE, line BC, but notice that it's a line. I can't emphasize it enough. You really need to make sure that you're putting those arrows on the ends when you have rays or when you have lines, because you've got to tell the difference at the end between having a segment or having a line or having a ray. Very, very important to do when you're doing these. Next, I want to run through the third example. If you take a look at the third example, it's asking me to look at the union of segment FE, EC, and FC. Remember, the union just unites those together. So again, the easiest thing to do here is to trace those and see what I get. Here's FE, here is EC, and here is FC. And you notice the shape that I drew there is a triangle. We haven't talked about naming triangles. You could just write triangle, FEC, or you can use the triangle symbol that looks like a triangle. And that's all you need to do there. Now to take a look at my last example, my last example is the union of ray EA and ray EB. Again, the rays, good idea always to make sure that you're drawing the arrows at the bottom or at the end. So EA starts here and goes out this direction. And again, don't be afraid to extend it past the diagram. There are times when you may see something more clearly when you do that. The union with EB, EB goes this direction. Again, notice I'm extending it infinitely, putting that arrow there. If you look carefully at what I drew an angle. You really don't want to call that angle E because we've got multiple angles at vertex E. I really want to use the full name there. This is going to be angle BEA. Or you could call it angle AEB. Either of those answers would be acceptable. I've a new set of problems here, and you'll notice that this new set of problems involves a different symbol. You'll notice that my U for union has now been turned upside down. And this new symbol is sort of an opposite in a sense. The symbol looks like this. It is called an intersection. And the intersection is really the overlap between two different geometric figures. So I'm going to do this a little bit differently. I want to see where two different things are overlapping. So I'm going to use two colors, and I'm going to see where I've used two colors. Again, really want to watch putting arrows on the ends of rays and lines because anything that's included as part of the final answer has to be part of the overlap, has to be double colored. And that's the place where people can very easily overlook things. Your most classic example would just be to have a line segment. Maybe I have a line segment with a few parts here. Maybe I have A, B, C, and D. And your most classic example might be something like the intersection of segment AC and segment BD. And you can draw this on the diagram. You can draw this like above and below the diagram if you don't want to mess it up. But what's really happening here is, so it's where AC, this segment, overlaps with segment BD, that second segment. And you'll see the overlap is happening anywhere where that green and that red overlap. Now, probably a little bit hard to see that in the video, but those colors are overlapping only between point B and point C. So the intersection of this would be said to be segment BC, the overlap, where they intersect, where they cross over, the kind of shape or geometric figure that's created at that overlap. So I'm going to use the same kind of strategies with these problems. Again, maybe a little hard to see on the diagram. You can do these with single colors, just kind of seeing where your pencil markings overlap each other. You can do it with color, really depends on how you think. First one I have is ray BE, which is going to go off in this direction. And again, notice I extend it. It goes on forever, even though that's not really shown in the picture. And it's the intersection with ray CE. Now this is tricky. Ray CE starts here, and it goes on in this direction, and you'll notice it's not overlapping the red ray, not overlapping the red ray, and now suddenly it is overlapping. And you'll see that I have a double color all the way through here, and that double color is going to continue on infinitely because that's a ray. So very important that I put that ray at the end. So they start overlapping, two colors here, and they continue to overlap forever. What does that create? That creates a ray. It's a ray that starts at E, goes out to B, so we would call that ray EB. Okay, I think I can do the second one, just kind of erasing this. Do that real quick here. Okay, so the second one is the intersection of DC and AE. They're both segments. DC is right here. AE is going this direction, and you'll notice there's only one place that gets double color. It's where those two lines intersect. That one single position is a point. So the answer here is just point F. That's all that's going on there. Now I'm ready for part C. C is the intersection of angle DAE and angle CAE. So DAE, and again, keep in mind an angle is actually made up of rays. So DAE, and that's going to go around here. And again, I'm going to draw those rays out going on infinitely because I don't know where that overlap is going to take place. So I really make it clear to myself, these aren't just segments, these are rays. Now I come back and I do it with a different color with angle CAE. So we have CAE. And notice, this goes on forever, this goes on forever. Intersection, it's an overlap where they cross over each other. You'll notice double color starts right here, it continues out. Notice that I have arrows for both the red and the green. Those are both continuing forever out. Starts here, continues out forever at the overlap. That's a ray. We would call that ray AE. And we're up to my final example of intersection. It's the intersection of line AE. I'm going to go ahead and draw that in red again. Notice it's a line. It's not a segment. It's not a ray. So I very clearly put arrows on both sides to show that it's continuing. It's the intersection of AE and FE. Check out FE. It's just a ray. So in a different color, I come back to FE. It just starts here, but it will go on infinitely to E. So notice I'm overlapping all the way along here. It will continue on infinitely. So it starts here. Notice the overlap continues for both of those infinitely. So it starts here, goes there. That's a ray. That's ray FE.